Hello students, today's discussing topic is magnetic field intensity through a solenoid by passing electric current I by using Biot-Savart law. Okay. So, let us continue it. Magnetic field intensity due to flowing current through a solenoid of finite length L using Biot-Savart law. Here this is a solenoid. We write some parameters, its radius R and flowing current I ampere and its length is L and turn density is equal to N. Okay. What is turn density? Turn density means number of turns per unit length, number of turns per unit length. This is called turn density. Okay. Now, this is solenoid having radius R, flowing current I ampere, having length L, turn density N. Okay. Now, by using Biot-Savart law, what should I do? How should I derive it? Then you know well, Biot-Savart is used to derive magnetic field for a elementary part, and by integrating it we find entire parts magnetic field intensity. So, we have to consider some elementary parts of that very solenoid. So, if we consider a longitudinal cross cut part of this solenoid, it seems as the figure. It seems as such. Okay. Now, with the help of this figure, we derive entire magnetic field intensity at point P, this point P. Okay. Here this is in, this is out. Okay. Now, suppose we have to find out the magnetic field intensity at point P, and for this we consider elementary part. This is stated also as a coil which is taken as dx, that means dx. Okay. Small, what is dx? Small elementary length of a coil. Okay. Now, what is the number of turns possesses? Because we know that turn density is equal to N. So, number of turns having this coil, this part dx is for a part, for a length dx of coil, total number of turns is equal to N dx. Suppose this is denoted by capital N dx. Okay. And I ampere current is flowing entire circular coil. Oh, okay. Now, this part makes an angle from point P, this is theta. So, and the distance between P from that very part dx is x. So, it is treated base perpendicular and this is hypotenuse. So, the value of this x square plus r square is square root. Okay. Now, with the help of Biot-Savart law, we know that the magnetic field intensity, this is dB, is equal to mu naught over 4 pi 2 pi I n dx r square upon r square plus x square over 3 upon 2. This is the formula that we know well. Okay. Now, 2 pi this. So, we may write it such as also mu naught over 2 I n dx r square over r square plus x square over 3 upon 2. Okay. Now, if this angle theta, so cot theta is equal to base by perpendicular, which is x upon r. So, x is equal to r cot theta. So, dx is equal to r minus cosec square theta d theta. This is dx is equal to minus r cosec square theta d theta. Okay. This is taken as first. Okay. Now, we put the value of x and dx, we get it. dB is equal to mu naught over 2 I n and dx. This is r minus cosec square theta d theta dx and r square this over r square plus x square, x is equal to r cot theta. So, x square is equal to r square cot square theta. So, we place here r square cot square theta over 3 upon 2. Okay. Now, dB is equal to mu naught over 2, this is minus I n r is multiplied by r square, this is r cube and this is cosec square theta d theta. Okay. And this is r square is taken common. So, r square 1 plus cot square theta, and this is upon 3 upon 2, and it may write further this way: dB is equal to minus mu naught over 2 I n r cube cosec square theta d theta, and this is upon r square cosec square theta, because 1 plus cot square theta is equal to cosec square theta, and this is upon 3 upon 2. Okay. Now, dB is equal to minus mu naught over 2 I n r cube cosec square theta d theta, and this is upon r square multiplied by 3 by 2, 2 cancel out, this is r cube, and this cosec square theta multiplied by 3 upon 2, this is cosec cube theta. So, we may write it cosec square theta multiplied by cosec theta. Now, what we observe is that cosec square theta and this cosec square theta is cancelled out, r cube and r cube is cancelled out. So, we may write it further: dB is equal to minus mu naught over 2, this is I n, this is 1 upon cosec theta upon cosec theta, I this, n this, and d theta, and this cosec theta. So, dB is equal to minus mu naught upon 2 I n 1 upon cosec theta, this is sin theta d theta. Okay. Now, what we see here, this is the magnetic field intensity for a elementary part. Now, we have to evaluate magnetic field intensity for an entire solenoid having length L. So, we have to integrate it. Okay. Now, one thing you should note it, suppose this elementary part exists there here, then it angle makes which that angle, an angle that make this. If we consider here this elementary part exists, so the angle making angle from P to this part, this is alpha, and on the other hand, when we consider this elementary part exists this area, this end, and now this angle is taken as gamma. Okay. Now, the limit of integration is alpha to gamma. Now, we have to integrate it. This is dB integration lower limit 0 upper limit b, and this is minus mu naught upon 2 I n, because this term is considered as constant. So, we make out from integration, and now we take integration sine of theta d theta, and the lower limit is alpha to gamma. Okay. Okay. Now, this b 0, okay, minus mu naught upon 2, this is I, and sine of theta, this minus cos theta, cosine of theta, and this upper limit gamma, lower limit alpha. Okay. Now, b minus 0 is equal to minus mu naught over 2 I n minus cosine of gamma minus cosine of alpha, and this is equal to b is equal to minus mu naught over 2, this is I n minus cosine of gamma plus cosine of alpha. It is written as minus mu naught upon 2 I n cosine of alpha minus cosine of gamma, this. Okay. Now, the fact that you should know, if we consider this beta, what happens? What does it mean? It means entire angle, this value, this is 180 degree, this is pi, and this is beta. So, this part this part which is known as gamma. Now, we may also write instead of this cosine of pi minus beta. Okay. So, we place here minus mu naught over 2 I n cosine of alpha minus cosine of pi minus beta. Okay. Now, b is equal to minus mu naught over 2 I n cosine of alpha minus minus cosine of beta is equal to minus mu naught upon 2, this is I, and cosine of alpha plus cosine of beta. Okay. This is magnetic field intensity, and negative has no importance here because magnitude of B, this is mu naught over 2 I and cosine of alpha plus cosine of beta, and this is a scalar form, and now when we take as a vector form, this is B mu naught upon 2, this is I, and cosine of alpha plus cosine of beta and x cap. Okay. Now, this is the required result. Magnetic field intensity at point P due to flowing current I through a solenoid having finite length L. Okay. Now, some facts you should know it. This cosine of pi minus theta or pi minus gamma, pi minus beta, suppose here pi minus beta, this is value, which formula we should use here, cosine of pi multiplied by cosine of beta plus sine of pi and sine of beta. Okay. Now, you should know the graph of cosine and sine. Suppose this plus 1 and this minus 1. Now, this, that means 0 cos 0 plus 1, this pi by 2, 0, this is 3 pi upon 2, this is minus 1. So, cos pi is equal to minus 1 and cos beta, this is equal to minus 1 multiply cos beta plus sine wave, this sine, suppose y is equal to function of cos x, and this 0 pi 2 pi plus 1 minus 1 pi by 2 plus 1. Okay. This is function of sin x. So, here sin pi 0 and 0 multiplied by something is equal to 0. So, this is minus cosine of beta, which is taken here. Okay. Now, we have derived the final result here. Now, there exist some special cases which here we discuss. suppose this solenoid have infinite length, that means if L, that is the length of a solenoid, tends to infinity, what happens? If the length of a solenoid tends to infinity, then this angle and this angle tends to 0. Obviously, then alpha and beta tends to 0. So, what happens? Now, case 1, solenoid is has infinite length, then what happens? This means magnitude of intensity, magnetic field intensity, that is B, is equal to mu naught upon 2 I n, and cosine of alpha, this is cos 0, plus cosine of beta, this is also 0, and this is equal to mu naught upon 2 I n 1 plus 1 mu naught over 2 I n multiplied by 2, and this 2 and 2 is cancel out, this is finally mu naught I n. This is the required value of magnetic field intensity for a infinite length solenoid. What we observe here, this turn density, if it is in ascending order, so magnetic field intensity also in ascending order, and when this is descending order, then this is also descending order. So, this formula is very important, so you should remember it always. Okay. And there are another case too. There is another case, too. Here we suppose that the solenoid is semi infinite length. What does it mean? It means one end is limited and another end is unlimited, suppose this, or this limited and this unlimited. Then what does it mean? It means this angle, if we consider this figure, now alpha is equal to 0 and beta is equal to 90 degree. So, what happens? B is equal to mu naught upon 2 I n cosine of alpha plus cosine of beta. Okay. What result that we find? This is B is equal to mu naught upon 2 I and cosine of alpha, this is 0, plus cosine of 90, which is equal to mu naught over 2 I and 1 plus 0. This is equal to mu naught upon 2 I. What we observe here? That means at the end magnetic field intensity is just half of the point P, or just like point P. Okay. This is the final result. If we plot a graph, this point O and minus L upon 2 and this plus L upon 2 and this point P, and when we take magnetic field intensity not touching that very point, this and this, suppose this point, this end A and this B, then the magnetic field intensity is this, but when we tends to the end, then magnetic field intensity decreases and this finally outside 0. So, just the graph, just half. If here mu naught upon 2 I mu naught I and N, and here just this mu naught upon 2 I and that means this, this, okay. This is the required plotting. So, I hope students this video is helpful for you. Even so, if you feel some doubts or trouble, you may comment and I will try my best to sort out your doubts or problems. Okay, all the best.